Okay, so now we're going to look at the factoring strategy, and it's going to incorporate all of the factoring that we've done in the previous lessons. All right, so this will be a mixture of problems. Some will involve just trial and error. Some will involve remembering something about the leading coefficient being a 1, difference of two squares, difference of two cubes, sum of two cubes, and so on. So the next few lessons will involve a mixture of problems. So we're going to call this one part 1. All right, so as we go through the factoring, it helps if you look at this factoring flowchart. So you can download it from Canvas. But first of all, you're always going to start with this question: is there a common factor? So remember, what we've done, if you go back through all the problems, is we look for a common factor for the GCF, and we factor it out. So if it's yes, you factor out the GCF. If it's no, then you ask yourself how many terms. Once you factor your GCF, you ask how many terms. So it kind of goes together at some point. So if there's 4 terms, remember there's 4 terms, we try factoring by grouping. All right. If there are 3 terms, we factor them into 2 binomials. And you could do this by using the AC method, where we actually wrote it in 4 terms, or you can use trial and error. It's up to you. It is to your benefit that you know both. If there are 2 terms, then you ask yourself, is it a difference of 2 squares? Is it the difference of 2 cubes? Is it the sum of 2 cubes? Okay, so remember, if it's 2 terms, you always look for these 3 ideas. Then over here, once you've factored in 2 binomials, remember, you always ask yourself, you always looked at each binomial and ask yourself, can you go any further with it? And so that's what this is. Check each factor, can it be factored again? Okay, so if it's yes, repeat the process. If it's no, this is your final answer. But don't forget about the GCF. Okay, and so this we won't do in here, but it is a possibility in college algebra. So we'll look at this in college algebra when we get to the factoring, which is a very small portion of one of the chapters. Okay, so as we go through this, we're going to look at this flow chart. Okay, so let's look at this example. So we're going to factor. All right, number 1. Suppose we had a squared minus a minus 6. So a squared minus a minus 6. All right, so remember, the first thing you do is ask yourself, is there a common factor other than 1? So is there a common factor other than 1? If yes, you factor out the GCF. If no, you go to this point. Once you factor out the GCF, you ask yourself how many terms there are. All right, so here we go. The GCF is 1. So there are 3 terms. And so since there are 3 terms, I'm going to go directly to 2 binomials. All right, now I can use one of several approaches. I can use the way that we did it when there was when the coefficient is 1, like it is here, or I can just do trial and error. It is up to you. All right, so this was probably best if we just do trial and error. So remember FOIL. And so for the first, what times what is a squared? Well, that's easy. That's just a. And then the last, okay, you want two factors of 6, but you want this last one to be negative 6. So remember, in order to get a negative, one has to be positive, one has to be negative. All right, and so remember, the outer and the inner, have to add up to be a negative a. All right, so for 6, remember there are two possibilities whose product is 6. There's 3 times 2, and there's 6 times 1. All right, but remember, we all know that the last term's negative 6, but just look at the absolute value for right now. All right, so if I put a 3 here, let's say, and a 2 here, and remember, I need the the outer and the inner to add up to be a negative 1. And remember, the last sign is negative, so that means one's positive, one's negative. So if I look at the outer for right now, a times 2 is 2a. I'm going to worry about the sign in a little while. 3 times a is 3a. The larger of these coefficients will take this middle sign. So that means that A is negative, 3A is negative, and 2A is positive. So, and that's the only way I can get, and if you look at this, a negative 3 and a 2A is a negative 1A, which is what you wanted. So our terms are in the right place. I just need to put the correct signs. So in order to get a negative 3A, or get a negative 3A, 3 has to be negative. In order to get a positive 2A, 2 has to be positive. So there's your answer. But again, always check yourself. A times A is A squared. The last, negative 3 times a positive 2 is a negative 6. That's what you wanted. And then our outer and inner, A times a positive 2 is a 2A. Negative 3 times A is a negative 3A. And when I add them up, I get a negative 1A. All right, so that's trial and error. So we did this by using the idea of trial and error. Now, if I use that product sum from a previous section, remember factoring by grouping? So basically, A squared minus A minus 6. So basically, you asked yourself, remember the product has to be AC, and the sum has to be B. So AC, A is the, now don't confuse this A with this variable here. So remember, this A that we're talking about is a coefficient of the squared term. So that's going to be 1 times C, and C is negative 6. C's are constant. So remember that's AX squared plus BX plus C. So that's where the A, B, and C are coming from. A is the coefficient of the squared term. B is the coefficient of the X term. And then C is your constant. And I need the sum to be B. So I need the sum to be, in this case, negative 1. All right, so the product has to be negative 6. Remember what we did? We looked at two numbers whose product is negative 6 and whose sum I need to be a negative 1. So for example, if I say 6 times a negative 1, well, that sum is 5. So 6 times negative 1 is negative 6, but when I add them up, I get 5. But remember, be strategic. You want the sum to be negative. So in order for the sum to be negative, when I wrote this, 6 and 1, the larger of these had to be negative. So that means this had to be negative. But it still doesn't help, because when I add them up, I get a negative 5. But at least I know this idea that if the last sign's negative, the two signs in here are different, and the larger of those, if I put the signs, the larger of those has to be this sum right here, this negative, this in this case negative. So if I try 3 and 2, all right, 3 and 2, the larger of these has to be this middle sign, so I'm going to have to make it negative, and when I add them up, I do get negative 1. So using the AC method and factoring by grouping, that means I can rewrite this middle term right here using these two numbers. And again, remember, it did not matter in what order you put them. So I get A squared minus 3A. Don't forget that I got to put A's with this, that middle term, the variables of that middle term, plus 2A minus 6. All right, so, and just check yourself, these two terms and add it up does give us this back. So this right here, this is the same as this. Now let's go ahead and factor by grouping. So I'm going to group the first two, group the last two. When I group the first two, I can take out an A. I can factor out an A. I'm left with A times A minus 3. And then over here, I can factor out a positive 2. And when I factor out a positive 2, I get A minus 3. And so from these two groups right here, they have an A minus 3 in common. So I get A minus 3 times, and remember, when you factor out an A minus 3, you're left with A plus, and when you factor out an A minus 3, you're left with 2. And so notice that this right here is the same as this. Okay? All right. Let's look at number 2. Okay, so number 2, we have, let's see, we have x squared plus 7x plus 12. So x squared plus 7x plus 12. All right, so again, go through the flow chart. Always look at GCF. The GCF is 1, so there is no common factor other than 1, so I go directly to this. How many terms are there? There are 3, so I'm going to go directly to binomials. All right, and then I'm just going to go ahead and use trial and error this time. So, using FOIL, first times first has to be x squared. So that's easy. That's x and x. All right, so that takes care of that. The last sign's positive, so that's going to be easy for us. Whenever the last sign's positive, then the signs in here I can automatically put. I know it has to be those signs. So since last sign's positive, that means that these signs in here have to be the same. A positive times a positive is a positive. A negative times a negative is a positive. But I want, when I do the out and the inner, those two have to add up to be positive. In this case, positive 7. In order for that to happen, that means both of those have to be plus. All right, so think about two numbers whose product is 12, and I want the outer and the inner to be a 7. So if you said 4 and 3, you're right. If you tried any other number like 6 and 2, that wouldn't work, because when you do 6x and 2x, you get 8x, but you want 7. So it has to be 4 and 3. And always check yourself before you go on. The outer is 3x. The inner is 4x. And when I add them up, I do get 7x, and that's what I wanted. So my outer and inner work. My last, a positive 4 times a positive 3 is a positive 12. That works as well. So this is your answer. Okay? So this right here is just you checking to make sure that everything, when you multiply it out using the FOIL method, you get this back. All right, number 3. Suppose we had 2x squared minus 98. 2x squared minus 98. All right, so I go through the flowchart again. So is there a common factor other than 1? Yes, there is. The GCF here is 2. So your GCF is 2. So that means that I'm going to factor out this 2. So you factor it out. So I get 2 times x squared minus 49. So 2 times x squared minus 49. All right. So now you ask yourself, how many terms are there? Now when I say the terms, I mean just kind of cover out the GCF right now and look at what's inside the parentheses. How many terms are inside the parentheses? Well, there are 2 terms inside the parentheses. All right, so 2 terms. If there are 2 terms, you want to think about what we've done. We looked at the difference of 2 squares, and we looked at difference of 2 cubes, and we looked at sum of 2 cubes. All right, so I know that in this case, since this is a subtraction, I'm going to look at either is it the difference of 2 squares or is it the difference of 2 cubes. Well, if you look at it, this is an x squared. So let's just check to see if there's a difference of 2 squares. So remember what we did was we kind of asked ourselves, are these perfect squares? So if they're perfect squares, in other words, I can fill this in, then this right here is the difference of 2 squares. So I get x times x is x squared, 7 times 7 is 49, so this is the difference of 2 squares. Remember what you had to do. So that means that the difference of 2 squares, I can factor it as 2 binomials. Your first terms are alike, your second terms are alike except for the signs. They're opposites. So these last terms are opposites. One's positive, one's negative. So I get x minus 7 times x plus 7. So that's how you factor x squared minus 49. And check yourself. X times x is x squared. A negative 7 times a positive 7 is a 49. And when I do the outer and the inner, x times 7 is 7x. Negative 7 times x is negative 7x. I do get 0x, and that's what I wanted. So there's no x term. You don't see an x term. All right, so now the answer now is going to be 2, don't forget your GCF, times these 2 terms, right? These 2 factors. So x minus 7 times x plus 7. All right, so there's your answer there. Okay, number 4. Suppose we had, suppose we had x squared plus 3x plus xy plus 3y. So x squared plus 3x plus xy plus 3y. All right, so let's look at our flowchart. Is there a GCF other than 1? So the answer is no. That's no. All these terms, the GCF is 1. So I'm going to go directly to how many terms are there? Well, there are 4 terms. Remember, that's where we did the factoring by grouping. So what we did was we grouped the first 2, we grouped the last 2. So in the first group, I can factor out an x. And so I get x times x plus 3. Always check yourself. X times x is x squared. X times 3 is 3x. And over here, I can factor out a positive y. These two terms have a y in common. So I get y times x plus 3. And notice if it's working out the way I want it to, then these factors inside the parentheses here are the same. So now I can factor out the common factor from these two groups. I can factor out the x plus 3, and I'm left with x plus y. So if I factor out an x plus 3, I'll get x. If I factor out an x plus 3, I get y plus y. And so there's your answer. All right, so that's number 4. All right, number 5, you have a squared plus a minus 3. A squared plus a minus 3. So again, you go through your flow chart. The GCF, always look at GCF. GCF is 1. So we ask ourselves, okay, how many terms are there? There are 3. So go to 2 binomials. There are 2 binomials, and we factor this using FOIL. So I'm going to use trial and error. So a times a is a squared, so no issue there. A times a is a squared, so that seems to work. For the outer, for the last, what two numbers multiplied together is a negative 3, and when I look at the outer and the inner, I get a positive 1. See, that coefficient here is a 1. All right. So for right now, just put the 3. There's only, since 3 is, if I cover up this negative, I know the last sign is negative 3. The last term is negative 3, but just look at the absolute value for right now. So for 3, the only possibility for a product of 3 is 3 and 1. So let's put the 3 here, the 1 there. All right. And let's see what happens. The outer is a, the inner is 2a, and remember, 3a, excuse me, 3a. And remember, I need, since the last sign's negative, that means these signs in here are different. So that means one of these is positive, one of these is negative. One of these is positive, one of these is negative. Okay, positive, negative, positive, negative. Well, the larger of these, remember, if I want this sum to be a positive 1, a positive, then that means that 3a has to be positive and that a has to be negative. But the issue is this. When I add them up, I get a negative 2a. And there's no other choice for 3. And I can't change the first terms because they're the same. So what that means is that this right here cannot be factored, so we say it's prime. All right, so that's prime. So a squared plus a minus 3 is prime. Remember, prime means cannot be factored. Can't be factored. All right. Okay, and let's look at one more in this group. So let's suppose we look at this one. All right, one more in this group. So let's suppose we look at, let's see, 125 minus 8y cubed. 125 minus 8y cubed. Okay, so again, look for GCF. The GCF here is 1. GCF is 1. So I'm going to ask ourselves, how many terms are there? Well, there are 2 terms. Okay, there are 2 terms. And notice there's a subtraction in the middle. And there's a cube. All right, so look for those things. Subtraction in the middle and a cube. So right away, 2 terms. Right away, I want to see if is this the difference of 2 cubes. All right. So if it is, that means if this is the difference of 2 cubes, that means that this right here I can write it as something cubed, and this right here I can write as something cubed. So 125 is 5 cubed, and 8y cubed is 2y. So this is the difference of 2 cubes. But remember how you factor the difference of 2 cubes. So remember what we did was we called this f and this L. All right, so remember that? So the difference of 2 cubes, remember, the difference of 2 cubes, I can factor as f minus L times f squared. So I squared the first term right here, plus, it's always you always change the sign here, plus the product of FL, and then plus L squared. And remember, if this is the difference of 2 cubes, the factor difference of two cubes and the sum of two cubes, you get a binomial times a trinomial. And this trinomial cannot be factored. Now that's assuming first of all that you look for a GCF first, okay? Always look for GCF first. If you factor out the GCF, and then this right here cannot be factored any further. So don't waste your time seeing that this trinomial can be factored further. All right, so here we go. So f minus L, so that's 5 minus 2y, that's our L, times, all right, now let's deal with f squared. So f squared, remember, means f times f. F in here is 5, so that means 5, that's f. 5 times 5, which is 25, so that goes here. Plus f times L, so that's 5 times L, which is 2y, and then 5 times 2y is 10y, so that goes here. And then L squared means L times L, so if L is 2y, I get 2y times 2y, which is 4y squared, and so that goes here. And so there's your answer. All right, so that was number 6. Okay, so that's going to take care of that part one of this.